Is your molding floor dragged down by 3 separate manual stations? Parts come out of the mold at 80 to 120 degrees. Operators taking them by hand get burned. Gate cutting sits at its own station, slowing the cycle. And then someone stacks the parts by hand. 3 manual steps, where the accidents and the cost pile up. See the real problem. Taking hot parts by hand runs 1 to 3 burn injuries per 10,000 operator hours, and OSHA and safety audits keep tightening. Gate cutting at a separate station adds a transfer and a chunk of cycle time. Manual stacking needs 1 to 2 people per molding machine. In a shop with 20 to 200 machines, that labor alone is a major cost. An integrated robot folds the 3 steps into one motion. The instant the mold open signal fires, the robot reaches into the cavity, takes the part, turns to the cutting station and trims the gate, passes inspection, and stacks it into the tray. Take, cut, inspect, stack. One continuous flow, with no human ever touching the hot part. 3 cores. First, a 5 to 8 second cycle, synchronized to the molding cycle so it never becomes the line bottleneck. Second, burn injuries drop to 0 because no one takes parts by hand at the machine mouth anymore. Third, quick change in tooling fits 80 to 1,000 ton machines. One robot specification covers the full tonnage range, instead of a dedicated gantry takeout per machine. Watch the demo. The machine opens, the robot's 6 axes reach in, a multi-suction gripper lifts the full mold's parts at once, moves to the cutting station to trim the gates cleanly, then stacks them onto the tray smoothly. The motion is continuous, paced to the molding cycle. One person watches from the side, and no one reaches into the machine again. By the numbers. Manual, 12 to 18 seconds per part, 1 to 3 burns per 10,000 hours, 1 to 2 people per machine. Integrated robot, 5 to 8 seconds, 0 burns, 1 person monitoring 4 machines, about a quarter person each. 3 separate stations become 1 robot. Throughput doubles, and safety and labor are solved together. This solution fits broadly: appliance housings, automotive interiors, packaging containers, medical devices, and 3C electronics enclosures. For pure take-in stack on a single machine, a rigid gantry takeout is fast and fine. But once you integrate gate cutting, inspection, or multi-machine service, an articulated robot wins. With 4 or more machines, 1 robot serving 2 or 3 pays back faster than buying 4 gantries. The core of injection molding tending automation isn't how fast you take the part. It's whether you solve burn risk, gate cutting, and stacking together in one motion. Your molding floor, how many burn injuries a year? Is gate cutting still at its own station?